Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God's willing, in these tutorials I'm going to show you how to fit in a second order polynomial regression model in R. So as you can see, I'm using RStudio as an IDE for R. So quickly I'm going to show you some methods on how to do that. The first method I'm going to use is the inhibit function. That's the inhibit interpretation or conversion of objects. It's called I function. So let's say, for example, I want to create a new variable called y estimate. That's the estimate of y. I want to estimate y on x containing linear model function. Then my response variable is y, then your tilde sign, my bad. Then your dependent variable, we have x, we have x and x squared for the model, right? So x, then plus, now I'm going to use the inhibit function. That's the inhibit interpretation or conversion of objects function, which is uppercase I, then open bracket, then you type in x to the power of 2. Okay, you type in x to the power of 2, meaning all what we're doing, the reason why we inhibit is to show that it changes the class of an object to indicate that it should be treated as is. That means what we are saying is it should be treated as x squared. Okay, so that's all for that. Then you press enter. Next thing is we need summary. Okay, summary of our y estimate, which is containing our model. So we have y estimate. So that's all. We can run our lines of codes now. So you can see here, this is my output. Permit me to maximize it, right? So this is my intercept, which is my beta naught minus 2.622 to the power of 4, and my beta 1 for x is 1.892 to the power of 2, and beta naught for x squared I have minus 3.313 to the power of negative 1. Okay, and these are their various standard error of estimates. These are their various t values and their p values. Okay, that's the levels of significance. And here we have our multiple r squared to be 0.8731 and our adjusted r squared to be 0.8224. Okay, f statistic here is 17.2 with 2 and 5 degrees of freedom. That's for degrees of freedom. 1 is 2, degrees of freedom 2 is 5. Okay, with p value 0.005734. That's for the model itself. Okay, it means the model is significant. And the residual standard error, we have 45.2 on 5 degrees of freedom. Now I'm going to use the poly function, okay, to actually run the same analysis again, so you'd see the differences, right? So now let's see. Let's say using poly function. Okay, using poly function. So this time around, I want to use poly function. Remember, I have my x and y's. Okay, so if I want to use the poly function, let's say I want to create the variable this time around. Let it be y hat for difference sake. Okay, defined or containing linear model of y on. Okay, now y on, this time around you're not using x plus I into x squared close. No, you're using the poly function itself. That's poly, open bracket. Poly means polynomial. This is a polynomial function. Then the first thing is your independent variable is x, right? Then you type in x, comma, then the degree we are considering is degree 2 because it's second order. Okay, so you have degree 2, comma, and the next thing we have is raw. The thing is your data a raw data? If yes, then let it be true. Okay, uppercase, I have true, or you can just type in uppercase T alone. Okay, true. That's all for this. Then all you have to do next is we have our function summary of, this time around is y hat because we're using this method. So this is y hat. Okay, you can run your analysis also. You see, it's the same value as you can see here. Permit me to maximize it also. The same, everything here is the same. with everything here. You can compare it and see, okay, these are our values. So what I'm saying is you can actually use the I function, you can use the poly function, okay, to get your answer. I hope you like this video. So for some of us that are smart, maybe probably you don't want to contain any variable in it. All you have to do is, let's say you don't need all of this. Maybe you don't want to have y estimate, you don't want to have y hat as a variable, you just want to have the summary directly. It means you have to create a composite function. So let me do it now so you'd see how to. So let's say I have, just bring this down. So let's say for the first method here, for the I function, so all you have to do is you just say summary of, now this time around you put in this model inside this linear model. So this is all you have to do, summary of another function, linear model of y tilde then x plus then your right function, which is your inhibit function, then open parenthesis, you now type in the argument, which is x to the power of 2. Okay, so that's all for this. You can actually run these codes, these lines of codes, you get the answer again. Have an error message. Observe here, this is y here and z, so it's supposed to be a tilde sign. Okay, so quickly I'll run now. Observe, the answers are all the same too, like the previous ones, as you can see. Okay, they are all the same. So let me show you the other way again. Now using this method, let me drop this down. I don't want to use this y hat. All I want is I want to use the summary function again. So let's see summary. Now in place of this y hat, you type in the other linear model. So I have linear model of, okay, now the response variable is y. Then I want to use the poly function. I need to be poly as function of independent variable x comma degrees. I have degree 2. My raw data, it's true, it's raw data, so it's true. If you like, you can write t, like I said previously, you can use the t. So let me use it so you know that you can actually use it. So you run, that's all. Have an error message, my bad. So invalid formula. Now let's check where our problem comes. I have lm. So here comes the problem. I'm supposed to have a tilde sign here. Tilde sign, okay? That's where the error comes. Enter. You see the results are all intact and correct, okay? So this last methods is just for some of us that maybe want to run it at advanced level, maybe you want to composite it, but I advise you all to use the variable container like in this method. But should you know what you're doing, you can run it at a go, okay?